One of the most important topic in understanding physics is vector. And what is a vector? Let's at first take an example. If we go to some shopkeeper or to a shop and we buy something, suppose we buy rice. How we buy? We just say give us 10 kg of rice, but we don't need to mention any particular direction, like give me 10 kg of rice in the north direction. That sounds absurd, definitely. And obviously we cannot ask a shopkeeper about oil and we say we want 10 liter of cooking oil in the south direction. This is meaningless, this is absurd. So these are the quantities which do not need anything other than its magnitude. For example, 10 liter and 10 kg. These in liter we measure volume and in kg we measure mass. So these are two examples of physical quantities which we don't need to mention with their direction. We can say they don't have direction. Such physical quantities which do not have a particular direction or which do not have direction, they have only magnitude, are known as scalars. They are another set of quantities, physical quantities. When we talk about them, we need to specify specific directions. We need to say direction. For example, when we navigate and we ask someone for direction or someone asks us about direction, what we say? We say go in the north direction a mile or 1 kilometer, and after 1 kilometer take a right turn and go or walk 2 kilometers and you will find your destination. Here what we are specifying? We are specifying a physical quantity that is known as displacement, and we are associating the magnitude, that is 1 kilometer and 2 kilometer, along with direction. Without direction we cannot specify location of a place. So there are some other quantities like force and velocity and acceleration. These quantities, whenever we talk about them, we need to specify their magnitude as well as direction. And in such scenarios we say these physical quantities are examples of vectors. So basically there are two types of physical quantities, namely scalars and vectors. Scalars are those physical quantities which do not need any kind of direction or which do not have direction, they only have magnitude. And vector quantities are those quantities or those physical quantities which have magnitude as well as direction. So one of the simplest example of vector is displacement. And we are going to discuss many properties and many things about vectors. The things which are applicable to the displacement, they are also applicable to any other kind of vectors. So don't worry about them, just understand and make your concept clear, and you will get a good understanding and you will be able to apply these vectors in your physics study in various chapters. Whenever you study or we study motion in a plane or projectile motion or force and other things, equilibrium, we must have a good understanding of vectors and how to add vectors, how to subtract vectors. And there are two kinds of multiplication involved with vectors, and one of them is dot product and the other is cross product. And if we understand these basic operations and properties of vectors, then we will be able to solve any kind of problem in our physics study. Now let us begin. What is a vector? A vector is a physical quantity which has direction as well as magnitude. So whenever we listen or we have a term vector, it means vector means magnitude plus, in addition to magnitude, there is direction. And example, one of the example we have already taken is displacement. There are many examples, but let us dive into displacement. Suppose there are 2 points, point A and point B. One thing is moving from point A to point B, and it is taking a path like this. So we have a path, actual path, and this actual path is known as distance. Length of the actual path is known as distance, and we have a straight line joining these 2 points. This is the shortest distance possible between these 2 points, and this shortest distance along with direction is known as displacement. So what is distance and what is displacement? Distance is the actual length of the path traveled by an object, and what is displacement? Displacement only depends on initial and final position, that is where the object was and where the object is. When we join these 2 lines, we get our displacement. This displacement is in a particular direction from A to B. If we don't specify, we only specify length and not the direction, then there are many possible directions in which one could move. So it is necessary, it is always necessary to specify direction, in which direction to move. So a vector can be represented geometrically with a straight line or a line segment. But here, for example, here we have shown this displacement AB with a line having an arrow. So this we can move here and we say this is a vector. In representing vector on a plane, we have this method of representing, geometrical method. We just draw a line with an arrow. This line, that is the length of this line, this represent magnitude of the vector. It means if the length of the line is larger, then its magnitude is larger. For example, here we can say this displacement, say AB, it is having a magnitude of 5 meter. Then if this is another line, say C and D, and it has the length twice of this line AB, then we have its magnitude 10 meter. So the length of the vector we are showing is directly proportional to the magnitude of the vector. The larger, the bigger the line, the more it has its magnitude, and these 2 vectors are in the same direction. So whenever we represent a vector, we draw a line in accordance with the magnitude of the vector, and we put an arrow, and the arrow shows the direction from initial to final position where the movement is taking place, or what is the direction of the vector. If we have another vector, this also has 5 meter length, but we can see this vector is pointing in a different direction. So this vector, say A prime, B prime, vector AB and A prime, B prime are having same magnitude, 5 meter and 5 meter. Are they equal vectors? No, they are not equal vectors. Always remember, for 2 vectors to be equal, there are 2 conditions. One of them is obviously they must have equal magnitude. It is one of the condition. This one condition is satisfied in these 2 in this case, but the second condition is they must have same direction, and the second condition is not being fulfilled here. So these 2 vectors are not equal vectors. So equality of vectors means if there are 2 vectors with same magnitude and in the same direction, only then they are equal vectors. And if any one of them is not fulfilled, then the vectors will not be equal vectors. And the second most important thing to understand that we can move the vector from one place to another place if we do not change its direction. Then there is no change in vector. For example, vector, this is a vector A. Say this is a vector A, and we can move this vector, take this vector here, this vector will remain A, here this vector will remain A. It does not matter where in the plane we draw the vector. If its direction and magnitude are not changed, then we can place the vector from one place to another place. Say this place to be first place, this is the second place, and this is the third place. Then in the plane we can move vector anywhere, and there is no problem in moving vectors. Similarly, there are many other properties which we are going to discuss.